Hello, this is Vasri from At Home Tuition. In today's lesson, we are going to learn the complex number, what a complex number is, and how algebraic operations are performed in it. That is what we are going to see in today's class. Let me first tell you what a complex number is. A complex number is always in the form a plus ib, where the a and b are real numbers. Okay, so what is this I represents square root of -1. Okay, so your I square would be square of this, right? So square of -1, that would be -1. Okay, so I square, you take it as -1 because your I is square root of -1. Okay, now I said the complex number is in the form a plus ib, right? Here the a denotes the real part of the complex number, and you call it real z because this complex number we normally represent with the letter z. So real z, and the portion where you have the I, you take it as imaginary part, and it is imaginary part of the complex number z. So here, when two complex numbers are given, say for instance z1 as a plus ib and z2 as c plus id, then you can say that these two complex numbers are equal only if a is equal to c and b is equal to d. Okay, the real parts should be the same and the imaginary part should be the same. Only then you can say that two complex numbers are equal. Okay, I'll just give you a small problem here. If 4x plus I times 3x minus y is equal to 3 plus I times -6. If this is given, what is x and y? So this is very simple. So I have told you already, the two complex numbers can be equal only if the real parts are equal, right? So you can equate. Here you have one complex number, here is the other complex number. The real part of these complex number is this and this, right? I am going to equate that. So that is your 4x, since they are equal, your 4x should be equal to 3, right? So your x would be 3 over 4. Is that clear? We can conclude that x is 3 over 4. We got the x. Now we need to find the y. Likewise, the imaginary part should also be the same, right? So 3x minus y should be equal to -6, right? So here you already know what is x. You can substitute x here. So that would be 3 times 3 over 4 minus y equals -6. So on solving, you get 9 over 4 here. So you get y equals 9 over 4 plus 6. Okay. So that represents your y is 33 over 4. Is that clear? So from this, what do you understand? When two complex numbers are same, your real parts would be same and the imaginary parts would be equal. Okay. Now, let us learn the algebra of complex numbers. So first, let me tell you how addition is performed between two complex numbers. So here again, z1 and z2 is given, and when you find out z1 plus z2, that is the sum of the two complex number, you would just add the real parts. So that is a plus c, okay, plus the imaginary part is added separately and you fix the I along with it. So I can give you the example later. Before that, let me tell you few addition properties, okay, the properties of addition of complex number. First one is closure law. It says that when two complex numbers are added, okay, the resultant would also be a complex number. The answer you get will also be a complex number. That is your closure property. Then next is commutative property, that is whether you add the first complex number with the second, or you add the second one with the first, it is going to give you the same answer. It is one and the same. And in associative law, you take three complex numbers. Here what you say is the first one, the sum of first one and the second complex number done first, and then when you add the third complex number to it, will provide the same answer as adding the first number to the sum of second and third complex number. The next is additive identity. The additive identity says that the existence of additive identity says that there is a complex number which when added to the another complex number would give the same answer. Say for instance, if you have a complex number z1 and if you add 0 complex number, that is 0 plus I0 to it, it will give you the answer as z1 only, right? So the identity is maintained. So this is the existence of additive identity. You can also call it 0 complex number. So here what does it say? I can say that a complex number plus 0 would give you the same complex number again. This is what is additive identity. And the existence, the last one is the existence of additive inverse, or you can say negative of z, negative of a complex number. So here what you say is, for every complex number you would have an additive inverse. So the additive inverse is, it is just, if z is the complex number, then the negative of z would be minus z, okay? So that means if z is a plus ib, okay, if z is a plus ib, the negative of z would be both the real part as well as the imaginary part is negative here, okay? So this would be negative a, negative ib. So this is the negative of z. So these are the 5 properties of addition of complex number. Understood? So let us see how do we add the complex number. Let me take few examples to show you how the complex numbers are added. Your z1 is 4 plus I3 and your z2 is 7 plus I4. Okay. So how do you do z1 plus z2? For z1 plus z2, we would add the real parts. The real part is 4 and 7. So you add the real parts separately and the imaginary part is added separately. Here you have 3 and 4, right? So your resultant would be, the sum would be 11 plus I7. This is your addition. Sum of two complex number is done this way. Now the next one is subtracting. How to do the subtraction of two complex number? It is nothing. It is so simple. When you have to subtract the complex numbers z2 from z1, what you do is z1 minus z2 is equal to, you write the z1 as it is, and to that you add the negative of the second complex number, okay? The negative of the second, that is minus z2. z1 plus negative z2 would give you the answer. So let us take an example for this too. Now let me take the same example there. We had a z1 as 4 plus I3, okay? And z2 is 7 plus I4, right? Now how do we do z1 minus z2? So this is very simple. You write the z1 first. So that would be 4 plus I3, right? Okay, this is your Z1. To this, you're going to add negative Z2. That is, negative of Z2 is going to be negative 7, negative I4, right? Change the sign because it is negative of Z2. So you have to change the sign of the real and imaginary part there. Now your answer would be 4 minus 7, right? The real part is 4 minus 7 plus, keep the I outside, and here you would get 3 minus 4, right? So that will fetch you 4 minus 7 is negative 3, and here this is 3 minus 4 is negative 1. Negative 1 times I will give you negative I. This is your answer. I would do one more problem here, one more sum. If Z1 is 6 plus 5I and Z2 is 3 minus 2I, okay? So your Z1 minus Z2 would be equal to, the first you write the Z1 as it is and add the negative value of Z, complex number Z2, right? So that would be minus 3. See, I said since it was positive 3 there, you have to change the sign. So that is minus C, negative 3, and here you have the minus already, that would become plus. You have to change the sign, okay, of both the numbers, both the real part and the imaginary part. So that would give you 6 minus 3 for the real part plus, keep the I outside, and you have 5 plus 2, and the resultant would be 3 plus 7I. It is very simple. It is like normal addition and subtraction only, but the only thing is that you would add the real part separately and the imaginary part separately. And also these properties are important. Go through these properties also. Okay. Thank you. See you in the next video. Till then, bye.